Today we will be solving CCC 2008 J1 Body Mass Index. This is going to be an explanation, so if you want to try this out, go to damoj.ca/problem/CCC08J1. Alright, and then pause this video, come back once you have an answer, just to see my thought process if you wish, or if you don't get it. Okay, so Canadian Computing Competition 2008 Stage 1 Junior 1. The body mass index, BMI, is one of the calculations used by doctors to assess an adult's health. The doctor measures the patient's height in meters and weight in kilograms, and then calculates the BMI with this following formula or mathematical model. Same terms. So here, this is our BMI. You're going to take the weight and you're going to divide it by height times 2, or to the power of 2 as well. Write a program which takes the patient's weight and height as input, calculates the BMI, and displays the corresponding messages from the table below. So here we have some ranges. So we have here, more than 25, between 18.5 and 25, and then less than 18.5. So if you're less than 18.5, you're underweight. If you're between this range, which is inclusive, so these two values are included, your normal weight, and then 25. If you're more than 25, this means that this value is not included. And you could also think about it as, if you're including it in this range, why would you include it in this range as well, right? Or this condition. So yeah, it's going to be more than 25, so 26 and onwards. And that's overweight, and then less than 18.5, so that's going to be 18.4 and onwards. Or here you could do 25.1, I guess you can think of. But anything above 25, not 25 itself. And anything below 18.5, not 18.5 itself. So you are going to be inputting, so it doesn't give us like the input specification, output specification, as this is an older question. But if you look here, it's older than me. But if you look here, it's asking us to take the patient's weight and height as input. So I'm assuming this is our weight and this is our height, because our height is being measured in meters, right? So it doesn't make sense for someone to weigh 1.73 kilograms. It's probably the meters, right? You can see that here as well, because these two are the heights. So this is our weight and this is our height. So let's go ahead and build out this program. So this was from before. Don't mind this. CCC08J1, the body mass index. Okay. So let's start off with our weight and height. So we have to first put in our weight, and that's going to be an integer, I believe. Yeah, our weight is an integer. But then our height is not an integer, it's a float. So we have to make sure that's a float value, because you can see here that we're getting a decimal value. But over here we're getting it as a decimal as well. So it's probably safe to assume that both are going to be float. And then now we're going to employ this mathematical model. So body mass index, I could use BMI too if I wanted to. And then we're going to do weight, right? And I'm going to just put these in brackets just to make it a little easier on myself. And then divided by, and then this operation, so that's going to be height times height. So there you go, we have our body mass index now. And then we want to run some if statements to make this work. So if I'm going to start from the bottom and go to the top, because that's what I naturally think about. I would naturally check if it's less than, then in between, and then above. So I'm going to say if body mass index is less than 18.5, print underweight, and make sure you had the capitalization, all of this counts. Now we're going to do an elif, in which we're going to check for this range. So it's going to be 18.5, and it's going to be less than, but in reality it means greater than, because we flipped the variable. and the value, right? Because it's usually the variable first, then the value. Here it's the value first, then the variable. So this sign has been flipped to show the change in relation. Because remember, everything's dimensional to one another. And then here it's going to be 25.0, and both of these are equal. This has to be a float value, by the way, because this is a float, so we can't compare it to an integer. And now we can go ahead and print out normal weight, just like that, with the space, because that's how it's given to me. And you can see that in the output as well. And then now, otherwise, it has to be overweight, because there's no other scenario that we have. So it's going to be overweight. There's no like error scenario or anything like that. It's just these three scenarios. And so if it's not normal weight or underweight, you have to be overweight. Right. So let's save this. Let's run the module. Don't mind this. This is from before, but 69 and 1.73. Normal weight. Let's try this one. To run the module again. Overweight, and you can see that's overweight. If I put this before I put it, I'm just gonna put it into some. I'm gonna put some comments. Float values because sample inputs were decimals. This is pretty self-explanatory. Specification. Okay, and then here, all I'm gonna say, these are just, I'm just adding this because I'm actually practicing for a test that I have, so it's just good for practice. And our teacher requires us to comment on our code so he knows that we did it and we actually understand what we wrote, because in computer science, it's pretty easy to copy code and then just pass it off as your own. Save that, and let's go ahead and submit this solution. And there you go. Well, it's very weak. There's only 3 test case. Okay, but yeah, there we go. That worked. Right. I'm gonna take this. I'm gonna add it here. I was supposed to actually code on here, like on Visual Studio Code, but I started doing it on the idle. So that's okay though. All right, that's it from me, guys. If you have any comments or any questions, you can leave it in the comment box below. Take care.